Hi guys, and welcome to another session for our practical for this tutorial. For this session, I think for the last couple of sessions we've been talking about SQL injections, and we saw how SQL injection can be damaging. We saw how to protect against SQL injections by validation and safely passing the parameters within the query. We also saw how you can use JPA, which is an ORM. And today we are looking at path injection as promised, that I'm going to demo a bit of a path injection. And essentially, we are going to be looking at how to simulate, we're going to simulate a path injection, and then we are going to protect against path injections, right? Again, by validating inputs. And basically, injection, as we saw in the theoretical part of this section, is that injections, one of the main reasons why you have injection is because we trust user inputs, which is supposed not to be, it's not supposed to be the case. We're not supposed to trust user input. So my name is Ngane Emmanuel, and you are watching the session, part of the series called Building Scalable, Low Latency, Secure, and fault tolerant API using Java and Spring Boot. So I'm a software engineer, and I'm going to take you for this session. Let's dive right in. So right now I went ahead and I implemented endpoint. We've already seen how to implement endpoint, so I'm not going to be doing this much, right? So I basically created a basic OS endpoint, and I did the request mapping, the base mapping, and then I created a get mapping for the particular endpoint, which says we are supposed to read the file. And basically, we are going to pass the file name as a parameter to this request. And then I also created a file service, which we use the injection, dependency injection. This is field injection, to inject it into this class, and we use it, and then we call the read file method, which is implemented in the file service, and passing the file name. So the read file method in the file service is basically going to take in the file name, and it's going to get the path, right? So it's going to get the path, and how it's going to do it, it's going to combine. Right now we are implementing the vulnerable path, and usually this is what they used to do in the first time, in the early years of reading files. And what they'll do is they will get the base path, something like this. Of course, you have to use on a production server. You will not implement, say, your base path directly. You don't have to code it like that. You use environment variables, which we'll see later on, or will be like certain things. We use environment variables, which we can also use variables from properties for now. And then we're going to call the path here. And what happened is they just simply they concatenate the file name to the base path, and they use it to resolve the path. And what we are going to do now is going to use the file class, and we're going to read the content of that file. So we're also throwing exceptions, and we're catching an exception. I also went ahead and I created this read file exception right here. It's a basic exception class, and I also went ahead and I implemented the global exception, the handler of the exception, which this is it. So nothing new, just same content we have been doing so far. Again, we have seen this before, we have seen creating exceptions before, so that is not new. So right now, I'm simply just going to spin up the class, so I'm going to clean that up. Sorry. I'm going to spin up the server. Again, our server runs at 8080. And I'm going to go to Postman. So while it's running, it's done running. Again, 8081. Where is it? There we go. 8081. So whichever port you indicated in your application of properties file, you should be seeing there. So I'm going to go to Postman, and I'm going to get the URL, and I'm going to put it. I'm going to create a GET request, and I'm going to put the URL there, right? And I'm going to go to parameters, click that, and I'm going to pass the key as a file name as we instructed in our controller class. That's what we are getting, the file name. And then you have to pass in the value. So right now, I created in my base path, as you can see, my base path, I created a folder called app and another folder within that called files, and then the file names are inside. I have two files there, file 1 and file 2. So I have one file there for now. I have file 1, and I think there was some content in there. So what should happen, at least what we're expecting for the user, should do something like this: file 1.txt, right? And this will be a good request, and this is going to return the content of that file. And so the content says that this is what the user should have access to, of course. However, we are trusting the user input too much, so the user can do something such as this. Okay, the user can say, okay, I don't want to read that file, I want to go one step back and I read a file maybe called secrets, right? And now the user is not supposed to have access to a file that is outside of this directory, which means that a file that is here, the user is not supposed to have access. We only want the user should have access somewhere here. So this is our application. Assume that is our application. This is not actually an application, but I just created a file to show you this is our application. We want the user to have access just to this folder, all the files in this folder. This is our acceptable folder. This is the only folder where the user has access to. But now the user can go one step back using path injection by using basic Linux path methods, queries, right? And go back one step and read your secrets. Now, if you have something like this, is a very sensible information, and it's damaging for a user to have it. So if I say I read secrets, you have some interesting secrets, there's some API keys, there's some very interesting stuff. The user can just go one step back, basic Linux command, and go // and then secrets, and secrets.txt, and read something like that, right? And that's what the user is not supposed to have. And so you see what happens is that your secret 1 is outputted and your secret 2 is outputted, right? And that is really bad. And the user can go even further, right? So a user can go 2 steps back, and that takes him to now. So where it goes is in the app directory, where it goes one step. It's in the app directory, right? Where it goes the other one is in the C directory. I can go now to say, let's say program files, right? That, so let me just manually do this, right? I can say program files. Oh, there's a space there. I think that will cause an error. I could just go users. I'm just trying to get something simple. Something that anyway. So this is is there like a text file here? Application install. Yeah, there's a text document. All right, so that's a text document right there. So I could go. There we go. I could go to XAMPP. I think that's how I spell it, right? Let's look at that. Yeah. Okay, so it's small letters. XAMPP, and then I could go password .txt. Alright, so I think that should be it. Alright, so -- exam password -- exam. Okay, passwords as with S. Okay, so it's S, and then that Z comes out from there. .txt. There we go. And you see, I have access to something that I'm not supposed to have access to. So Imagine a user now have access to all your passwords, the username, it gets the root user, it gets the password, um, everything. So you get information that isn't supposed to get information to. And that is very bad, so bad, in such a way that, it could, with this information, they can do a lot of damage to your system. And so this is one of the problem with bad injection. This is one of the problem with trusting user inputs. You don't validate user inputs. You leave yourself vulnerable. So let me keep that there. So how do you fix it? Well, essentially, you want to always validate user input. All right. So we are going to refactor this code, and what we are going to do here is we are going to, we're still going to get like a path. Right? We're going to go path, a base path. So what we're going to do, we're just going like uh, base path, right? Right, and this will be get, and we're simply just going to get base path, right? So what I want to do is I want to just get the base path right now, and um, I want to read it as a real path, right? And that's going to get the base path. And now what I want to do is now get the resolve the total. I want to resolve both parts, the base part and the finding. So I want to resolve both part and normalize it. Okay. What this does is, if they send a query like this, okay, if they send a query like this resolves the part by removing the dash 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 and gives you the actual path. So for example, when I send a query like this, the actual path now that is going to send for something like this will be C. Okay. Um, so it's going to be C, and it's going to be XAMPP, and that's going to be password. .csc. And this is the kind of path that particular, if I send that request, this will return here. It's not going to return a dash dash slash dash dash slash on top of that. No. So basically, when I send that path, what you'll be expecting to see is this, and then you have dash dash slash dash dash slash, and then XAMPP. Yeah, this is what you are hoping to see, right? But no, when this normalize does is after resolving the part, after doing this, right, it normalizes it by giving you the actual part. So it removes all the redundancies and the slashes to give you where it's actually pointing to. Okay, so what we can do now is we can now check if, right, the resolve path starts with the base path. So as you can see, the resolve path does not start with this base path. So you are going to have a problem. So we have to check if it starts with the base path, right? If it does not start with the base path, what do we want to do? We want to throw the read file exception, could not read file, right? And that's all. Again, you don't want to give the user a lot of information. No, you just want to give as generic of the information as possible. And what we're going to do is we're now going to read the resolve path, right? And that's still the same code, just a little bit refactor for security. And we're going to try to rerun that, and we're going to see how that solves the problem. At least the basic generics, right? But the idea of what I'm teaching is that do not trust user input. You could do additional verification for if it's an upload link, you could check for file length, file size, file type, and basically validate user input. You could check within the bytes themselves, right? So you could do a lot of checks. So if I try now to send a request like that, could not read file. Why? Because we are throwing an exception here, right? But now this is throwing a 500 exception. Oh, okay. So this, oh yeah. So we're throwing a 500 exception. It's an internal server error. So read file exception. Yeah, so we'll just leave it like that. But you could give the user maybe like a clue. Maybe it's not his fault. But in this case, therefore, you have to tell him like it's a client error. But again, do you want to tell them if it's a client error? I mean, they are trying to hack your system. You don't want to give them information as if it's a problem with their system. Let them change their possibilities. Right? So you could do a lot of things, but if you want to like give maybe a different response, yeah, you could do a different response code because this is why we're getting the 500 internal server error. But what could we do? We could do like bad request, status, bad request. There we go. We could do bad request, okay, and that's going to give you I think a 403. Is it 403? Let's try that. 400, sorry, 400. 403 is 4, is it 4 billion? Yeah, 4 billion. Yeah, it's 400, so bad request. And so, yeah, so you could do bad request, could not with file, and this is a client side error. And so basically, they are kind of okay, I cannot verify that validates my input and so on. But so that's a basic validation. So you could do additional validation depending on the scenarios. But so what I'm saying is the two injections we have tested, there are other types of injections as we have seen, there are other types of vulnerabilities, and we're going to be looking at them. But for injection vulnerability, we are done by these two. These are the simplest for me to test. And I hope that this makes sense. So very important, do not trust user input. Always validate the input and your parameters, and make sure that your system is secure. Catch errors and return and handle them safely so that your system should not crash just because a user sent a wrong type of input. Okay, so that is very important. This has been a good tutorial, and I hope that this helps you when building your APIs to, to, to build it with security in mind. My name is Ngane Emmanuel. You can connect with me on my social media. Please check the description below. Also, the link to the GitHub repo where all of the files for this course are being. The link is in the description below. Right? The GitHub repo is in the description below. That said, is there any other thing? If you have any questions, troubles, comment below. I'm going to respond to you. Like, share, and subscribe. For our next classes, we're going to be looking at a new topic, which is details. What I will do before then is refactor the entire code for it to be cleaner so that we can have, because I think that we have, well, I don't know, I wanted to use response entity, but I'm just going to leave it there for now. Anyway, so this is good, and until next time, have a nice day.